Welcome back to Introduction to Computer Networks at NTU. This is Polly again, and I see you guys are now getting familiar with the lecture environment. I see many pop up on the live chat already. Good for you. So typically I would greet you back one by one, but towards the starting time, I won't have the time to do that. So good morning to all of you. I think morning Sherman, good morning Kelvin, good morning Brian, good morning Josephine, good morning. Excuse my display's resolution. So I'm using a couple sort of low-end displays. So I cannot tell the character. Su Wen. So I actually can't tell what that character is. Okay. So Wen Qi, Wen Qian. If you can type up the English spell of your name, that would help tremendously. And Yu Cheng, good morning. Kenny, good morning. Ying Liang, good morning. And guys, please excuse my... Ji, I see. So it's a special character. All right, Wen Ji. Thank you for letting me know. So excuse my Chinese. So I'm fluent, but my Chinese is so bad. I can tell you, knowing a few languages myself, Chinese is one single hardest language in this world. All right, enough chit chat. Let's go on and do the first thing we do every lecture, which is to go over the announcements. And typically for Wednesday, because we did all the major announcements already on Tuesday. So what you see more often on Wednesday is just the links for the live lecture and the Google Meet for the office hour. And therefore, we can go quickly to the topics. And let me give you a very high-level overview of what we are going to go over today. So there are going to be two sets of topics. First is to complete the overview of the class. Okay, so you see that Polly likes to make sure things are clear instead of trying to speed things up overly so that you miss many of the details. So I think it's okay. Let's take things slow, especially at the beginning. Once you get used to the format of the lecture, then we can try to pick the speed up. All right. Now the second half of the topic is finally, let's start by talking about the internet. And the second half today, it's going to be a very, very high level view of what internet is. Okay, good. So now the first topic, content of this course. Before we talk about these chapters that we have in the textbook, let me start by explaining why the prerequisites are important and what we are looking for from you guys having fulfilled the prerequisites, what we would expect in this class that you guys have come prepared for. Let's talk about the technical content we'll be covering this semester. So this will be your first course on the internet. We do not assume you know anything about the internet, but we assume you have the basic knowledges about computers and you know how to program. That's why these courses are the prerequisites. You must know how to program. You must also know what's inside a computer. So you need to know how to program using a compiler-based programming language, such as Python, C, C++, or Java. Now, if the only programming language you know is JavaScript, be careful. That's a scripting language. The coding style is somewhat different. You might need some time to adapt yourself into the compiler-based programming language's programming style. You need to know the computers. Inside a computer, if you recall, there's CPU, very important, right? The memory, also very important. And then there's hard drive, display, keyboard, the peripherals. Between the main components and the peripherals, there's a bus, okay, that's connecting everybody together. The thing together is a computer system. Internet. In order to access the internet, we add one more peripheral called the network interface card. So this card here is another peripheral that allow the system here, allow the computer here to send messages out onto the internet to another computer. In this Introduction to Computers course, you should also learn about within a computer. We pass data around as well between the main memory and the hard drive all the time. Okay? What's so powerful about the internet and the relevance of this course to this Introduction to Computer course and Operating System course is that internet, network interface card, extends the reach of the data we are producing or we are looking for from within the computer to outside of your computer to the internet. So definitely must have Introduction to Computer Networks. If you do have advanced programming training or you have taken courses about data structure or better yet algorithm and operating system, great. Those will work to your advantage. But be careful though. Internet, as opposed to operating system, we have a whole new suite of mechanisms that we need to learn. Programming, doing sake programming. So sake programming is the kind of programming we'll be doing. It's very different from the other programming assignments you run into taking the data structure course, taking an average computer programming course. taking a machine learning course. In those courses, you learn the API to do computations mainly, okay, to do input-output. You most of the time try to come up with an algorithm or better algorithm to make sure that things are complete or complete real fast. Okay. The kind of programming we're doing, socket programming, is to ensure that we call the API in a correct way and we send the message in the right format so that the computers outside on the internet will be able to take the message in and interpret the content and send the corresponding responses that we are asking for. And once the message is in, we need to know the API to extract the data, interpret the content, and send more message, okay, accordingly. So the type of programming we'll be doing here in this course, very different from most of the programming assignments that you run into, taking a computer programming course, taking a machine learning course. Okay. Yeah, so you see the programming assignments we have are very different. They are simple and yet difficult for students who are not familiar with system programming. Okay, that is why introduction to computer is one of the prerequisites. You need to know the architecture of the computer in order to do well with the system programming. All right, now let's talk about the chapters. The video is a little bit long, 4.5 minutes, but it's almost like a crash course of the textbook. All right. And here's how we are going to introduce the internet. We'll break it into components and introduce them one at a time. So you'll learn about what these components are. Most of the components are straightforward, but some of them, there could be mechanisms running to sustain the operation of the internet. So we'll learn about how these mechanisms work. We'll go one more step further. Learn about why these mechanisms work this way. Okay, you'll see that there's certain classes of problems that network engineers repeatedly trying to address. Mainly about how we make sure the messages are received correctly. Mainly, the messages are delivered efficiently. Internet is the subject of our study here. We know it's huge. Not only because we have many machines connected to it, but also there's so many mechanisms being designed and implemented for it today. Now, in order to introduce them, we try to break them into categories. Okay, and the way that we categorize things is we call them layers. So it's kind of, 1, 2, 3 layer. Okay, some at the top and some at the bottom. Okay, the top layer is called the application layer. Second, transport layer. Third, network layer. Bottom, link layer. Now this is also about the order of the chapters in the textbook. Okay, at the top, we talk about the mechanisms support individual applications operation. Each application typically one mechanism to determine how messages are being sent and how messages are interpreted when they come back. Okay. So in the application layer, we have many applications. We have a high diversity of applications on the internet today. And each of them, application layer mechanism, or let me introduce the term, protocol, application layer protocol. One application, one protocol. And this protocol is determining how you send the message out. So at the application layer, many protocols, each of them very simple, serving the purpose of the application they're designed for. Specific, simple. One layer down, the transport layer, you'll see that the number of mechanisms that we need to design and implement much smaller. Okay. You can count them using within 10 fingers. Okay. So number of mechanisms quickly shrink. And the mechanisms we need to design are to serve more general purposes. For example, how we send data correctly, reliably, how we send data efficiently. In fact, these functions are there to support the application layer protocol, because some applications might data to send reliably. Some applications might data being sent efficiently over being reliably. Okay, so you see one layer down. Mechanisms fewer, more general, and slightly more complicated. one more layer down, the network layer. So the functionality quickly shrink down to just two. The two mechanisms are called the routing and forwarding. So these are the mechanisms that's running in the very center part of the internet. So hey guys, didn't we just say that the internet, on it, many machines are connected to it? So I and my machine connected to the internet. You guys, your machines connected to the internet. But all these machines are called the end systems, and we are called the end users. To connect the end systems together, there is a core network, the internet core. And that network is composed by many routers. These routers, the reason they're called routers is because their main functionality is to find a route so they can forward messages. So my video here gets to you, forwarding the video segments to you. Okay. So at that layer, even fewer functionality, even more general functionality. And you can imagine the mechanism being even more complicated. So in that chapter, you will then run into an algorithm that you might learn in the algorithm course. All right, so yeah, many layers. The thing is this, although on the video, the link layer is crossed out, but as Polly checked the schedule this semester, there's no overlap of the lecture hours to holidays this semester. So, good news this semester is that we'll be able to cover some of the protocols in the link layer chapter. Now, these protocols are similar to the transport layer protocols, where we talk about data transfer from one user end to another user end to end. The link layer protocols handle data transfer from one node to another, machine to machine. So these machines are directly connected through a wired or wireless link. Yeah, so we might have some time to go over some of the link layer protocols. So you see that the internet protocols, many, each simple, and then gradually shrink at the network layer, really tight. Very few, very, very general, but down to the link layer, it's once again expanding because we have many link layer technologies these days. For example, Ethernet, Wi-Fi. Ethernet is the wired technology, and Wi-Fi is the wireless version of the Ethernet. And there are actually many more. So many link layer technologies, each will implement its own protocol. So people actually say that the stack of the internet protocols from the top to the bottom is like an hourglass, with a thin waist at the network layer. All right, so very high level overview of the chapters we're going to go over, and a very high level overview of the internet protocol stack. Now let's go over the semester schedule real quick. The semester is going to run in 3 parts. In the first third, we have 5 weeks of lectures followed by an exam. Second part, 4 weeks of lectures followed by an exam. In the last part, another 4 weeks of lectures followed by an exam. And in terms of topics going backwards, in the last third, we will cover the link layer a little bit, and then mostly the network layer protocols. In the second third, mostly the transport layer protocols. In the first third, mainly the application layer protocols, but we'll spend more than a week time to give you an overview of the whole internet. Now, in terms of assignments you need to turn in the first third, there are 2 programming assignments due. First 2 are somewhat straightforward, but the third one is very challenging, and that is why week 4 is left empty. What that means is that you want to start working on PA3 from week 4 so that you can make the deadline, March 22nd. In the second third, we do have back-to-back PAs, and no worries, because these 2 in the middle are straightforward. And that is to balance the load a little bit. In the last third, we have 2 PAs due, but PA8 is again a little bit challenging for some of you, so you want to start from week 12 to be safe. And now, grading. So the first video is just to give you an overview. It talks about how you earn grades from the programming assignment, from the pop-up quizzes from also the exams. So there are actually three kinds of assignments or exams that you need to work on in order to earn grades. So let's hear out the overview of how you earn grades. Now let's talk about how you earn grades. You will earn the grades in three categories. The first one is called homework. You'll be working on these programming assignments, also known as the PAs. There are 9 of them. First one is straightforward, counts only for 3 points, but the rest of the 8, each 4 points. So together, 35 points to earn here. In the second category, interaction, that includes the quizzes as well as the participation. There will be about 50 of these quizzes that will pop up during the lectures. Altogether, you will earn 30 points. How much more you earn out of the 30 points depends on how complete you are answering all these quizzes, as well as how you are more responsive, meaning faster answering the quizzes, as well as how you are more thoughtful and the answers are more unique. Participation. This counts all the interactions with, between you and the class. Okay, so asking a question or answering questions from others in the class will all count. And interaction through all kinds of channels such as Discord, email, YouTube live chat session, as well as the Google Meet video session that you might be using for office hour. So all of those counts, and together maximum 5%. Last category, exams. This one is straightforward. There'll be 3 of them, each counts for 10%. And this is another way to break down the 100 points you'll be earning. PAs and quizzes, together 65 points. You'll be working a team, so these will be teamwork. Participation in exams, together 35 points. This will be work as an individual. But, from the proportion, you see that it's very important how you are working as a team. So each team will consist of 1 to 3 members. So this is in case you are a loner, and 3 is the absolute maximum. But the same group of people, you'll be working through the semester for these assignments. Now, every now and then, some students will ask to break up, and that is allowed. All right, so that's the overview. And you see that we weigh actually more relatively to other courses on the interaction part. There are 35 points for interaction, okay? And teamwork is a lot more important than the individual work. Good, so let's go over each of the 3 parts in detail and pay attention to the due days and if you miss the due date, due time, what the penalty is, how much the penalty is. It's actually proportional depending on how much late you are. So let's start from the programming assignment. And you will hear what the programming assignments are. They're actually related. And there are actually 2 major components in the programming assignments. Okay, homework assignments. So these are the 9 PAs. They are the golden programming assignments. For the purpose, we'll be setting up a Unix workstation. Each of the team will be given an account so that you will submit your code and test it also on the workstation. The TA and I will be grading your assignment based on how well your code runs on the specific workstation. Stage 1 of the PAs consists of 6 assignments. And the goal is for you to learn how to create a TCP socket, establish a connection between 2 processes on the internet, and pass some data around. Okay. And we'll be doing this through a toy internet service that is allowing file uploads. Okay. So you'll be implementing a client that uploads a file and a server receiving the content of the file and storing the content into another file. File upload, file transfer service. Just a little bit more about each of the PAs, all right? PA 1 is for you to learn some Unix commands so you know how to work around the Unix workstation at least. Second, using Golan to access files. Okay, this is about reading from a file on the hard drive, maybe do some processing and then write change back to the file. Okay. I have assumed that you know how to do this using at least another language that you learn from the programming class, such as Python, C++. Okay. And more seriously, from PA3, and it's going to be a little bit challenging, You'll be writing the client side of the file upload service. So your client will create a TCP socket and establish a connection and connect to the socket of the server that the TA and Poly has already set up running on the workstation. PA4 asks you to switch sides, so you will be the one writing the server and allow your own client to connect. PA5 is to extend the server such that your server not only read from a file once and then done, it will continue to loop, taking a file and then back to wait for another upload, taking a file, wait another upload. So you could handle multiple uploads sequentially. And finally, PA6, just like all the servers for the internet services these days, they should be working, of course, looping forever and seemingly handle multiple clients uploading files simultaneously. Okay, so parallel multiple uploads at the same time. Okay. Stage 2 of the PAs consists of only 3 assignments, okay, but they are not easier. The goal is to learn about this web server implementation that is built in already in Golang. So one doesn't need to implement the web server from scratch. Instead, reuse the existing code and create your customized web server. Let's talk about each of these PAs also a little bit more. Now in PA 7 and 8, we'll introduce the function calls and some of the lower level codes of the web server in 2 parts. One is the request interpreter, the other is the response sender. So the request interpreter and the response senders are the 2 very important parts that compose a web server. So web server is first receiving web requests from the client, understand what the request is asking for. That's why it's called the interpreter. And then the server can generate a response and sends the response back to the client. Okay. And finally, in PA9, we'll make this web server a secure web server, which is the default standard these days for any internet services. You want your server to be secure. All right, so that's the programming assignment part. Now the pop-up quiz part. And Polly will talk about the penalty submitting these assignments late. So quizzes, each is an assignment. Programming assignments, each, of course, an assignment. The in-class quizzes, these will pop up randomly during the lectures, and they're related to the topics we're talking about. So for many of these quizzes, you'll be given time to work on during the lecture. So I would advise that you guys establish some sort of channel within the team so that you can have some sort of discussion before posting the team solution on the score. There's going to be a channel on the score per quiz, so it's hard to miss. Now, to earn the grades for the quiz part, you can solve it in class or off class, depending on whether it's take-home or not, and just type your solution up. In one of the quizzes, you'll be invited to speak and interact directly with Polly if you are lucky. Okay. So again, post your solution on the score and do it by Saturday, 6 p.m. Of the week that we posted the quiz. And so it'll be first graded on the completion rate, and that would add to 25% of the semester grade. And 5% will be reserved for those solutions that are particularly fast or thoughtful. So take your time for some of the quizzes, and for some quizzes, you want to be fast. There's a penalty for the late submissions, guys, so be careful. If it's beyond the deadline but within an hour, 10% deducted. If it's more than an hour beyond the deadline but within 6 hours, 20%, and so on and so forth. All points will be deducted if it's more than a day late. Class participation part of the grades. So this is easy. All interaction counts, but be careful. In order for the TA and I to count your participation, you need to let us identify you, all right? So make sure that on the YouTube chat, Discord, or in our emails, or when you join the Google Meet session, you use an ID that is recognizable, similar to your university record name, okay? And so let me and the TA and the other students know who you are. And the participation points will be scaled to the min and max of all the points assigned to the participation part of the grade. So that will be 0 to 5. All right, so let me just add that the submission deadline for the pop-up quizzes are the same. I'm sorry, submission deadline for the programming assignments are the same as the pop-up quizzes, Saturday, 6 p.m. And the penalty applied to late programming assignment submissions are also the same as the pop-up quiz submission, okay, as the late pop-up quiz submission, all right? Now, the last part, exam. It's actually more straightforward. The exams are hard, but grading the exams are straightforward. Exams. There are 3 of them, each 10%. The questions on the exams are all in these Q&A forms. I would advise that you go to the class page and go through some of the old exams to get a better idea. And for this semester, sorry guys, no early or makeup exams, please. There's also a penalty for the late exam submission. So if it's late but within a minute, 12 points deducted. Beyond 1 minute but within 2 minutes of the deadline, 25 points deducted. So if it's beyond 3 minutes, yeah, all points deducted. For every exam, you will receive a score after grading. But you see that in the end of the semester, when we are calculating the semester grades, we'll try to adjust the exam scores because the class average per exam can vary from exam to exam because of the difficulty or because of the length of the exam. All right. So we will adjust such that all 3 exams will align to the same class average. And that adjustment is a simple constant shift. All right. Last but not the least, guys, you don't want to cheat. You can do better than this. All right. But in very, very unfortunate case that we discover cheating behavior, 0 will be granted for the whole semester and the case will be reported to the department and further up to the university. Okay, so a key point here Polly would like to communicate and stress is this. Submitting the exam late, the penalty is severe, as you see. Okay, so it's not worth it. Okay, you know what is the ending time of the exam. So you want to make sure that you stop working on the exams before the ending time. Otherwise, just a microsecond beyond that, that is 12 points deducted. Okay, so that's the third part. But what about the semester grade? How is semester grade assigned? And this is the video explaining how Poly actually calculates, aggregate all 3 parts of the grades and come up with the semester grade. Semester grade. So we are assuming that a sum of 60 being the passing score for the semester. Okay, but in the end, you'll be assigned a letter grade. Okay, and this letter grade is derived from doing this. Okay, so for each of the categories, you will receive a numerical grade and we'll sum them up and you guys will all be ranked by the sum. And some of you will be assigned to the A+ or A or A- or B+ class, and the cutoff points may vary from semester to semester. Okay, but the goal is such that the concentration, okay, will be at about A- and B+. That's between 3.3 to 3.7. So average is going to be about 3.5. Yeah. Again, let me Polly add to the video. The B+ to A- average. Okay, that was a couple years back. Last year, if you recall one of the videos Polly played yesterday, we're actually shifting towards the range of A- to A. Okay, whether that's going to happen again this semester, I'm actually not quite sure. So it really depends on how you guys perform relatively to the previous semesters. You see that Polly tries to calibrate across the semesters and across the departments in the university now. Good, and the last video about the course is just the class material. Class material. The textbook is called Computer Networking, a Top-Down Approach, the 7th edition. Now, if you have the 8th edition, that's even better. But the 7th edition will be sufficient because the differences are not that many. For programming assignments, the Golang socket programming, I would advise using this book, which is online and completely open. Additionally, we have the lecture slides as PDF and available from the course page. Lecture videos on Polly's channel, YouTube channel, and everything else on Discord. And all these, we have links available from the course page. And it's time for quiz number 2. All right. Let's see. Let's go to the whiteboard setting. Yeah, so Polly can then dribble here. So this is quiz number 2. What you need to do, what you guys need to do for quiz number 2 is first, form a team. Okay, and as you heard, it can be composed by 1 student to 3 student maximum. All right. And after that, answer 4 questions. First is whether you can write Polly email messages in Chinese. Second, what is the exact day of exam 2? Third, what is the penalty if you submit PA1 at this time? Okay, so what is the penalty? What is the exact day? Okay, and can you write Polly email and messages in Chinese? Last is, hey, for the live YouTube chat, is it okay to type up questions in Chinese? Okay, can you? All right, so answer these 4 questions. So post all these as post these on the quiz 2 channel. So remember, in quiz 1, you find W1 quiz 1 channel. That's where you post the solution for quiz 1. And so you need to find the channel for quiz 2. And obviously, it should be, right? W1 quiz 2. And so you need to type up the name and student ID of all the team members. And after that, your answers to these 4 questions. Clear? And as usual, you'll be given time to work on this. And forming a team might not be trivial. And some of you are international students, for example, and you don't see the other classmates. And so what you want to do, perhaps, is to go to the random channel and introduce yourself, okay? And guys, domestic students, you might know some of the students in the class already, and you probably form a team of 2 already. And you could also post saying that, hey, we are a team of 2, and we're looking for 1 more to join, okay? So if you like to be alone, it's okay, okay? Just stay quiet. And type up your name as a lone wolf for your team, and then give the answers to the 4 questions. All right. And this one might take a little bit of time. So how about, guys, 7 minutes to work on this? Oh, nice. And as you guys are typing up the solution, you might find that it's not exactly easy to type up a post in multiple lines. So something that you might want to try is this, called the, let's see. So hit the shift and then combining it with enter. That would allow you to go to the next line and continue to type instead of just, if you hit answer without the shift, it's going to be just 1 post, 1 line. Okay, so hit the shift and then hit enter. That allows you to keep typing in the second line. Okay, good. Yeah, you know what? Let's go ahead and work on the quiz. 7 minutes, and let's start counting time. Sorry, yeah, let me, yeah, go on with the music. So I'm switching to the Discord mode so we can see how you guys are doing. All right, so hey guys, look at the Discord board. I know that some of you are still forming teams or just typing things up, but no worries. Again, the pop-up quizzes and the programming assignments are due Saturday, 6 p.m. All right, and what I want to draw your attention to is this. As I see, you guys deciding to form one-person team or two-person team or three-person team. What I do is this. As I see, for example, in Sam's case, that's a one-person team, and I would reply to that. So because Sam is the first one providing the solutions, I say towards the end, you see my reply that Sam, you are team number 1. And the second group typing up their team composition and the answer to the questions, yeah, you guys are team number 2. Okay, good. And also, I go over the sample solutions a little bit more. For example, Sam said here, if it's emails and messages offline, off class, definitely try to write it in English. And I'll just ignore Chinese emails from now on. And the exam 2 is on April 30th. And if you submit a PA or a pop-up quiz late beyond an hour, the penalty is 20%. Mm-hmm. Now, I guess the last question is a little bit tricky. I see that some of you say yes and some of you say no. So what is question number 4? Can you type up questions in Chinese in the live YouTube session? Yeah, it's because it's live. Yeah. Sometimes when you're short of words, and if timing is important, for example, reminding Polly that there's no sound, in that case, yes. Okay. But if you try to write in English, that would be great. Much like what team number 2 here says, Polly prefers writing English. Okay. So in a way, this is enforcing you guys to have a experience for domestic students. Okay, this is to enforce so that you guys feel like you are an exchange student without being physically abroad. All right, good. So Ethan will be team 3, and therefore Kai Xiang you'll be team 4. Okay, and because the lecture time is very precious, so I'm gonna do the team assignments, okay, after the lecture today, okay. But you guys get the idea. And I see that the random channel is very active. Great, guys. Try to form teams, all right, and try to be nice to each other, okay. And if you guys distribute PA assignments or pop-up quiz, try to make sure that you don't miss the deadlines. Otherwise, right, it's gonna be awkward. And you feel bad, okay, to your teammates. So in a way, the reason that the team part of the grade is 65% is also to reflect what real life is more about. Unfortunately, human beings are social animals as well. Although that you might be more an introvert, still, you can't live alone. It's hard to live alone, all right? Good. So maybe some of you will reconsider. So some of the lone wolves, think about it, and maybe to merge with other teams. So so you know what, guys? I'm gonna do the team assignments later on Saturday, so that, for example, let's see. For example, Kai Xiang, Ethan, and Sam, if you guys have a change of mind and you decided to merge and form a team, or form a team with another one-person team, or join a two-person team, that is okay. Okay. Later in the second week, we will still allow merging of the teams or breaking up of a team. Okay. All right, so that's quiz 2. And you know what? What time is it? It's already 11:06. So I guess what I can do is to do this. How about we go on to start the first video of a very high level overview of the internet. Okay, and so the first video is in fact the flow of chapter 1 of the textbook. Oops, actually no, we'll skip the flow of chapter 1 and go ahead and start with the physical view of the internet. Okay, so here's a 5-minute video. Now, what is the internet? So this picture that I'm showing is a very coarse-grained view of the internet, where you can kind of see that this part being the ISPs, okay, internet service provider. All there are in these ISPs are just these cylinders with the cross, okay, indicating that this is an exchange. So ISPs, the machines in there are mainly there to do data exchange. And then you guys are here, most of you guys are here. In NTU, NTU is an institutional network where you might be accessing the internet through wireless AP, so this is Wi-Fi. Some of you might be sitting in the dorm and having wired connection, having a PC accessing through wired connection. And some of you might be sitting at home, then your laptop connecting to Wi-Fi AP, and then connect to your ISP, and then to the rest of the internet. Now, some of you might be sitting in a cafe. That would be nice, I know. And then you guys are probably accessing the internet through your 4G network and watching the video on the laptop. That is a mobile network there you are accessing, or you can just call it wireless network if you want. Okay, so this is just saying that there are a number of different ways, a number of different kinds of access to the core of the internet. Now, in a little bit more detail and give you the full nuts and bolts view, so meaning the components. So first of all, you see the entities we're using as users are all these, okay, computing devices, PC, server, wireless laptop, smartphones. Okay, and these things are called hosts, or more professionally, end systems. Okay, we don't just call them systems because there's one common feature among these spatial hosts. They are all kind of sitting at the very end of this huge internet. Okay, end systems, very edge of the internet. And then, as I mentioned, right? So whatever machine you're using, whatever end systems you're using, you're connected somehow, right? To a cellular tower, right? To a Wi-Fi AP, to a institutional switch. Okay, so inside NTU, there are also a number of these routers exchanging data because we do have several departments, right? So you see typically institutional networks, there are a few more level of hierarchy than the home network, than the mobile network. But some of you could be accessing the NTU PEEP, a wireless network to the internet. All right. So these access networks, what I meant by access network there are not really there's a network. Okay. Really, they are communication links. Right. So if it's wireless, then we are using a radio link. If it's wireless and through a satellite modem, it's a satellite link. Now, if you're connected from home, chances high that it's a fiber link. Now, if you are connected through Ethernet I know for sure is copper link. All right, so these are different communication links we might use to access the internet. They can be wireless and wired. Now, these different access link or communication link technologies are all slightly different in terms of this, the transmission rate, the number of bits they can transmit per second, BPS. Now, in this course, computer networks, we also call this transmission rate the bandwidth. It actually meant more the width of the communication band, okay, of the network band. Now, this is somewhat different from if you take electromagnetic wave courses when we're talking about, oh, there's certain frequency band in the EM waves that we're using to transmit modulate bits. Okay, so bandwidth there is also referring to the frequency band. But here, the bandwidth, we actually refer to the network channel band. All right. At the abstract level, it's also a band, but we actually meant the band of slightly different things. And last, very important entity. Most of us don't see a router in our everyday life. If you want to see one, I don't know,
check out these videos released by Google and showing their data center. All these, slim boxes there is a router, okay? And they are running all the time, passing data, forwarding data in really high speed, okay? And by the way, I'm actually saying the routers forward packets because on the internet, the data are usually divided into chunks, okay? And these chunks are referred to as packets. So later on, you'll see me saying data packets or data messages. Okay, I actually meant things that are similar, right? So routers, well, there's just one thing, routers. Of course, these routers are manufactured by different companies, so therefore there are different brand names like Cisco, like D-Link, yeah, lots of them. Juniper, there's another one, a major one in the States.
All right, so you see, in that micro internet that you see, there are end systems at the edge of the internet, and in the core we have many routers, and between the routers and connecting the end systems to the routers are these communication links. Okay, so that is the physical infrastructure of the internet. And there was a question from Sing. What is ISP? Yeah, it's an internet service provider. These are the companies that you subscribe your internet access to. Right? So for home access, typically you pay companies like Zhonghua Dianxin, or you pay companies such as Taiwan Dageda, Taiwan Mobile, for internet access. So those big companies are called the internet service provider. Okay, they provide you access to the internet. In exchange, they get your money. All right, I hope it's clear. And you know what? It's 11:14. Let's take a break, and we'll resume the lecture at 11:24. Okay, 1 second. Oh boy. So guys, there might be construction noise the rest of the lecture today, unfortunately. Yeah, I'll figure out how I handle this issue. So my office is in the Berry Lam Hall, and there's some major construction in Berry Lam Hall all across, from floor, I think, 3 and up. So we'll see. We'll see how bad this is going to be. Good. So, hey, we just give you a very high-level overview of the physical infrastructure of the internet. There's just one more video I play. The end systems you see in the picture typically are computers. They could be laptops, they could be smartphones, they could be servers. But you see, nowadays there are these things called the Internet of Things.
All right, so let me say a little bit more about the end systems with this slide. Laptop, PC, servers, smartphones. These are the things we typically use to connect to the internet. But nowadays, if you go to these electronic shops, if you go do a little bit shopping on the Amazon or PC Home, you see there are these generation of new things coming along, and they can all be connected to the internet. They're called these IoT, the Internet of Things. Yeah, things is a very general term because these things don't have a specific form. So they could be internet-capable toaster, internet-capable power meter, internet-capable mattress, internet-capable fridge. And this is a picture frame. Okay. So for example, tweet a watt. This is a smart meter that connects to the internet, and this meter can actually take the reading and go on Twitter and tweet the reading itself. So you can imagine that the power company, power suppliers, energy suppliers can just take the readings from Twitter without taking a trip, okay, to your home. Smart mattress, right? So this mattress can sense how you sleep overnight and provide some feedback to you. This can further be made into something that's a little bit robotic, not just being capable of sensing, and so try to adjust the firmness of the mattress so that to ensure you have a good sleep. Smart fridge, I always like to have one of these. So it actually takes, there are cameras inside, so they take actually photos of the milk. So sometimes when I was in the grocery shop, I would really like to know whether I should be buying milk today. So this smart fridge will be able to remind us, okay, when we're in the grocery shop, whether it's time, okay, to buy milk. Picture frame. I think this is one of the very, very old IoT device. It's connected to the internet, and it was using a way that, hey, so you guys can send recent pictures through these IP frames to your grandpa. So you give these IP frames as a gift to your grandpa, grandma, and so that every day they kind of see different pictures from you. Now this one is Polly's favorite. It's a smart toaster. So what it does is that it will go on the web and retrieve the weather, okay? And so when you're making the toast, you kind of burn the mark corresponding to the weather today. So as you're eating it, you know the weather seamlessly, okay, without needing to check on the web. Nice, isn't it?
Yeah, so all these IoT devices, now they're connected also to the internet, are also end systems, right? And so from the micro picture of the internet there, you see that end systems with a couple routers, they form a network itself. And another group of end systems connecting to another set of routers form a network itself, a group itself. And then these groups of computers, these groups of machines will then also connect. Okay, so you have smaller networks, and the internet is a connection, a network of these smaller networks. Okay, so a lot of times we say that the internet is a network of networks.
And so those covers kind of all the components that's composing this very coarse-grained internet. But on top of the physical structure, there are also these rules, okay, that's controlling sending, receiving of the data, right? Such as, this is probably the third time that I talked about this term, TCP. HTTP is the protocol, the set of rules, okay, overwatching how you send data over the web. Yeah, so pretty much for each of the service, there is a specific protocol. For each type of service, for data transferring, there is a specific protocol. And so you see in general, the internet is a network of networks. So this is what? A network of a sub-network, right? So institution network is a network. Home network is a network. Global ISP forms a network. Regional ISP forms a network. And the internet is actually the bigger network of all these smaller networks interconnected each other. And it's loosely hierarchical. Why? If you look a little bit closer, yeah, this mobile network is connected to actually a higher tier ISP, while this home network and institution network is actually connected to a lower tier, a regional ISP. Okay, so it's not necessary that mobile network is level 2 or level 3. Okay, in this case, it's actually level 2 at the similar level as the regional ISP if they share the global ISP. All right, so this is what I meant here. It's loosely hierarchical. Right? And there are parts of the internet being public, okay, meaning everyone involved, okay, in the society in that region, okay, they will try to donate and to take part in contributing the expense of running that public part of the internet. But for most part of the internet, it's now private. So for NTU, an institutional network to access the institution's ISP, usually we pay. Okay. Similarly, at home, you pay the ISP for access. Similarly here, if you're using 4G, yeah, you pay someone to get access. So these, as long as you're paying, that means you're accessing a private network. Okay. There are occasionally public network, not a whole lot, but usually public network, the reason that we don't pay is because essentially we are contributing part of the work, okay, sharing part of the cost already, okay, by forming a consortium and paying a specific membership fee.
Yeah, so the internet, the physical side of the internet is a network of network. And these individual small networks, some are lower tier, some are higher. So there's actually a hierarchy in this network of networks. So just keep this in mind. And now we switch topic to talk about internet, but this time we talk about the software side of it. Okay, so we just finished talking about the physical side. Now, INET service view. Let me explain what I meant by service view.
Now the service view. To explain, we've learned, right, the nuts and bolts that's composing the physical internet. That is the communication infrastructure to allow us to actually have these applications sitting at the very top at the first place. But the communication infrastructure on its own will not be allow us to send data really that freely. So we could do surfing, we could send emails to each other. Between the apps and the infrastructure, we still have a number of these communication services defined by these protocols, okay, that's running on each of the devices, running in these routers. Okay, so there's a software component, a service component there as well. Now, two major classes of services that are provided by the internet are these: reliable data delivery versus the unreliable data delivery. Okay, so internet, essentially, it's not just a physical infrastructure, but also infrastructure with software support so that we could run all sorts of distributed apps on top of the whole thing. There's just one thing I want to clarify. For unreliable data delivery service provided by the internet, a lot of times we just call them the best effort service. Yeah, I know it's a little bit counterintuitive because reliable data delivery is obviously better than the unreliable data delivery. Okay, so why calling the unreliable service the best effort service? Yeah, take note here. We're saying this is best effort service. We're not calling it the best service. Yeah, this is a kind of a polite way of saying that, hey, there's no guarantee. If you recall cases where your friends asking you for favors, but you are not, that you don't have time for it already. So a lot of times what you say to your friends, right, politely is, I'll try my best. Okay, so that's what we meant here, calling these unreliable data delivery services the best effort services.
Yeah, so you get the idea. So the internet infrastructure is just the physical infrastructure, the machines. Okay? In order for these machines to communicate, you need to write software on top of that. And we call those software the services. And some software might be designed such that it provides reliability, and some provides maybe a short delay service. So there could be different level of services, different quality of services, or different types of software running on the physical infrastructure. All right. So essentially, the internet is the physical side, the infrastructure, and then the software side, the services running on top of it. Okay. The next video is to explain this term called protocol. Yeah. So internet is a communication network. So we have machines, and in order for internet to be really useful, right, you want the machines to send messages to each other and communicate. Okay, so the set of rules defining how the messages are sent and what each of these machines will do next, reacting to the messages, is called protocol. Okay, so here's the video to explain, and you will see in the video two examples. One is a human communication protocol. The other is a computer communication protocol.
This is so that I can impress you more about this term protocol. It is a slightly more formal way of calling a set of rules, okay? Calling a standard way of parties communicating with each other, all right? So two very simple examples I'm giving, and as analogy to another. One on the left is a human protocol, okay? One asking for another person for information. The other is an internet protocol. One end system asking another end system for information. So you see here, very often when Alice wants to find out what is the time, she says hi, right? And then maybe a friend here catching, Alice needs a bit help. Bob says hi back, okay? Showing that, okay, what do you want to know? Alice says, have you got time? And Bob provided the information that Alice is looking for. Similarly, we as users might be sitting in front of a desktop using a web browser trying to get the content from this URL. So yeah, that browser sends a message to the web server that holds the content. And that server will say, sure, you got my attention. What are you looking for? Client sends, I'm looking for this page. And server sends back the content, okay, of that URL is indicating to. So that is a simple protocol in human world and in the computer world. To sum it up, a protocol, it can be a human protocol or a computer protocol. Okay, so that example you just saw is for Alice to ask Bob for a time, a client asking for a server for certain information, or for you to ask a question. For example, if you raise your hand, right, that's like you saying hi. And if Polly noticed that, Polly says, okay, good. What is the question? Then you start by asking the question, Polly answering the question. So that is the protocol to get a question answered. Okay. So for people first meeting each other, how do you introduce each self to each other? Yeah. So there are specific protocols that allowing human to communicate with each other. Okay. So they are usually involving specific messages and specific actions taken after the messages are received. Right, and then so on and so forth. All right, you know what? That's very similar in the computer network. Okay, and the parties involved are just simply replacing humans with machines. Okay, and so all these communications happening in the computer network, okay, are governed by these protocols, where we define messages being exchanged and the orders of them being exchanged, and the actions each of these computers, each of these entities, need to take after receiving certain messages.
Okay, very important. A protocol defines what? The format of the messages, the order of the messages being sent, and the actions the end systems will take, receiving or after transmitting these messages. Good, and that takes us to quiz number 3. Okay. Yeah, this quiz is a bit special and it's going to be a little bit challenging, Hassan. Let's go to the whiteboard here. Okay, so this is quiz number 3. Yeah, Polly likes to read. So this is an article I found from Wall Street Journal back in 2013. And the title is The Delicate Protocol of Hugging. So you see from this picture, yeah, the lady on the left is a little bit, uncomfortable, okay, with the guy hugging her. So I guess the relationship is not close enough for hugging yet when they greet each other. So you see, greeting is a good, important part and very frequent part of human communication. But greeting itself can be complicated, especially, hey, you guys, this is an international class, right? So some of the exchange or international students are probably Americans, and some are probably from Europe. And last year, we have a Japanese in the class. So people coming from different region, coming from different culture, greet differently. So Americans like to hug. Latinos and Europeans like to do the kisses or touches on the cheeks. In Japanese, a lot of times bow, right? In the 90-degree bow. Hey, but most of the world, the rest of the world, what's universal is to just shake hands. But during the COVID period, right? So we no longer shake hands. So things can be a little bit complicated. Okay. Now, in order to be polite or to be proper, and so that you make friends instead of intimidating the people you run into, okay. A lot of times, what we do is to do the people we want to make friends, okay, with. So you want to be you want it to be appropriate, so you do what the others do. Okay. Now, the challenging part is this: how do you know? Okay. How do you know? Oh, where's my dribbling pens? How do you know if you should bow, shake hands, hug, or do the kisses on the cheeks, or else? Okay. Yeah, this one is very open-ended. So you'll be given 10 minutes time, and you now have already formed a team. Okay, so gather your teammates, have a discussion, and type your solution there. And by the way, starting from quiz number 2, I see that for quiz number 2, you guys, there are probably multiple members in a team. So each member actually posted the team composition and the answer, which is no longer necessary. Once you have the team, okay, so at least starting from quiz number 3, make sure that when you post your solution, write your team number or list the team member. If you don't know the team number yet, list all the team members and your solution. Okay, so you guys have 10 minutes and let's start counting. So guys, there are quite a few solutions already. So why don't I go over a few of those so you guys can get some input and develop your own way of greeting. So team 6 probably. Okay, Caesar here. And I guess Yuhan is the teammate. Caesar says it depends. Yeah, that's a very general solution. General answer, yeah. And Yuhan says, if it's not clear, right? try the most polite and universal way to be safe. And if one can actually start talking before greeting, yeah, of course you ask where the people you're running to is from. And that should clear things, and then you can do the move next. Right, so yeah, Yuhan and Caesar are teammates. Kai Xiang says, simply asking, where are you from? So that kind of addresses the issue, exactly which region this people you need to greet is from. And Jonathan is saying this, observe. Okay, so instead of approaching and greeting first, wait until the person act and then you react. Learn how people in different countries. Oh, okay, so team one is interesting. So of course you want to know which region the person is from. But hey, another factor they consider is how familiar you are to the person. Okay, some of these guys you run into, you might know where they are from. And you might have met the person a couple times. Okay, but how far you can go really depends on how you feel the two of you are close, right? Yeah, and that can be also a little bit complicated, isn't it? And Team Xuting and Yongping says, yeah, just go ahead and ask. Yeah, or simply shaking hands and bowing. And Hassan here says, yeah, try not to intimidate with the too close physical contacts until you know the person well enough. Okay, maybe mostly just talking, speaking. And how about what we did for quiz 1? Say hi. Yeah. Fun fact. Oh, Hassan is from LA. The most common greeting among youth is known as dabbing up. Yeah, you know what, guys, I just Google it up. And actually, I just copy the link from Hassan. Right? It's kind of touching hands in certain way. Okay. I guess it can be, it's a little bit like fist bumping, but more complicated than that. There are probably a variety of dabbing. So it'd be nice if Hassan, you can demonstrate exactly how it's done. And Calvin here. Yeah, say hi, say hello first. Okay, good. Yeah, and Calvin felt that at the beginning, it's probably safer to be passive instead of, being more aggressive or offensive. Yeah. I will observe and follow what other people do. Yeah. I think in Asian in general, avoid physical contact to begin with. Yeah. Ding Shen. Okay, Ethan. If I'm not sure where the people are from, I might just shake hands. Very good. Anthony, say hello. If it's hard, if there's not enough information to converge to a good solution, take the safest one. Very good. So you guys are thinking like a computer. Devin, do research of how different countries. Oh, wow. Okay, so hey, guys, this is a computer, right? So 3 steps. It's almost an algorithm. Cool. Okay, research the cultures and then observe or find out what culture they're from and then act accordingly. Okay, very good. Solution from a team of geeks. And this is from Brian and Nyan. If there is any doubt, just ask. Yeah, I guess you guys all get the idea. So greeting is to, as a way to try to make friends. And so you don't want to scare people off. So it's always better to be, to keep your distance. In the meantime, try to show that you're friendly. All right. So, 是恩. Okay. Just ask, are you fine? Shaking hands. And then this is a team. From Mehmet Lopez and Xuan. TCP3. Okay. One person sends one message and hosts the greet asking if they want to shake hands. The host of the greet receives the message and returns answers. If it's negative, send back a message to the greeter denying the greeting method. The greeter will get either the positive, all right. Okay, now this is very, very algorithmic. Yeah, it's very much like the TCP's three-way handshake. So that's how two-end systems, okay, find out whether it's okay to establish a connection and keep on talking. And James, representing the team here. So Kenny and Jaden. Depends on the environment, person, and situation. Okay, 3 factors. When in doubt, observe and follow the person that is greeting us. Follow, okay. But I guess what you meant by follow is a copy what they do, right? Or just, follow their lead. They will start with the bowel movement or move forward for a hug. Yeah, usually when people want to hug you, they would actually open the arms first. So there are signs you can observe to know what the other person intends to do. Yeah. Yeah, greeting depends really deeply on the culture. There's no way you hug Japanese, right? Even family members. I would observe their body language. There you go. Okay, let me just tick here. And greet them in the same way. If it's not clear, okay, if the body language is fuzzy, then use the most conservative way. And Bing Wei and Ming Qing. Yeah, simply ask, right? Or prevent physical contact before you are sure. And let's see. Qi En Shi Yun and Ming Lun. How the other person follow the local customs and social norms. If unsure, handshake is usually a safe and neutral option. Yeah, good. Very good. Yeah, so that's you guys' answer for quiz number 3. So this is an example of open-ended question. Okay, so human greeting is a kind of a protocol. Okay, and now let's wrap up. Okay, this very high-level overview of the internet.
Now to wrap up. What have we seen so far? Yeah, we do have these hosts or end systems where we run applications. They are sitting at the very end, very edge of the network. And these end systems connects to the internet through the access networks or communication links. They can be wired or wireless, okay, and through different kind of physical technology, physical media technology. And then finally, reaching the core of the internet, okay, which are essentially interconnected routers. Okay, and with all these together, we see the internet is a loosely hierarchical network of networks. All right, so this is the internet.
All right, so that video is also transitioning us from chapter 1.1 to 1.2 and 1.3. 1.2 is about the edge of the internet and the physical cables, the physical media. And chapter 1.3 is about the internet core. All right, and so that takes us to chapter 1.2, the edge of the internet. So let me introduce the edge of the internet in a little bit more detail. You know what it is, essentially the where the end systems are, but now a little bit more detail, okay? That I will introduce this term called access network.
Now let's take a closer look into each of the components, and starting from the edge. So essentially we have lots of these end systems running applications at the edge. Two very dominant examples, web and email. So for example, this guy here, a laptop, this guy here, a server, okay? Usually server are higher end machines having more computation power or higher amount of storage. So web browser will be talking to a web server requesting for a web page. Okay, so that is called client-server model application, where the client requests for services and receive services from the server. And you see that the expectation of these servers are that they run all the time, 24/7. And that's why these servers need to be higher-end machines, having more computation power, having higher amount of storage, and have more reliable internet connection. Okay, so as we mentioned, web browser here, web server here. Now, some of the pairs could be running email. Then you have email client, which is typically the email reader. And then there'll be email server. So these email servers, usually you don't get your hands on, okay? You don't see them. Just like the web server, you don't typically see a machine, okay? Physically, that is a web server. There's another way of communicating the end systems, the applications running on the end system, that is called the peer-to-peer model. Okay? The idea there is to get away without this, always on server. Now, imagine, right? Setting up a web server yourself and allowing thousands and maybe millions of clients in the world to access your web server. You do need a lot of what? Money, right, to maintain it. But some applications might be more grassroots effort, where you don't want to be able to afford servers and yet you still want to be able to exchange data. Yeah, that is what the designers of these peer-to-peer applications are thinking. Let's minimize the use of high-end dedicated servers. And instead, why don't we, right, smartphone, laptops, desktops, laptops, just, connect directly as peers, one to another. So there do exist several of these peer-to-peer applications. Skype is one example. BitTorrent, I'm sure that some of you have used it before, is a very dominant example. It's still very popular now. And besides these two, there's one example that you might go, oh yeah, that's right. It's called the Bitcoin or cybercurrency. So that blockchain allowing the cybercurrencies to track itself is a peer-to-peer network. So there's no particular server. That is the whole idea of having these virtual currencies. Okay, instead of having a central bank to overlook everything, to track, record everything, to monitor any of the currency exchange, virtual currency, Bitcoins, it's completely distributed. It's peer-to-peer.
So the end systems, the services on top of the end systems can be in two modes or two levels of services, client server versus peer-to-peer. And now, more formally, let me introduce the term access network.
Now let's move a little bit inward and talk about the next component, access networks. We know by now access nets are there to connect the end systems to the edge routers. What we haven't talked about are that there are several of these access net technologies. In fact, in the next few slides, Polly is going to talk about 5 of these. And depending on where they are used more often, they are classified into these 3 categories: residential, institutional, and mobile. Residential meant home access. So some of these access net technologies are used more at home, deploy more for home environment. Some of these are used more for institutions such as NTU. And some are wireless, okay, so people can still access the internet as they're on the run. For example, 4G is a mobile access network. Now, as Polly gets into the details and talk about each of these access net technology, try to pay attention to the bandwidth each of these technologies promises. Some of them offer higher amount of bandwidth, some lower amount, and some offers symmetric amount of bandwidth between downlink and uplink, but some offers more downlink and less uplink. Pay attention also to how the access net is being used among the users. Some access nets give you this amount of bandwidth, but all the users accessing the network will share the bandwidth. So if there are more users, each one gets a smaller cut. But some technologies actually offer big bandwidth, and that access net will actually allocate a specific amount to each of the users. So each of the users will be guaranteed a specific amount, which is dedicated. Okay, and if there are more users, none of the existing users will suffer.
All right. You know what? That's access net. There's a variety of these access net because if you compare residential internet access to an institutional access, so residential access usually is lower, okay, and the institution network demand is higher. Okay, so there are different levels of service that different users seek. Therefore, there are different access net technologies. So what you're seeing here in topic 10, there are 5 of these access net technologies, which we'll cover the first thing next week. All right, and you know what? That's all the technical content we'll cover this week. For the rest of the time, let me draw your attention to this question on Discord. It's on the Ask Us Anything channel. A student asked, may I ask, does it mean that the release date of PA1 will be on February 25th? Because according to the schedule, PA1 is due the second week, and maybe it will be released February 25th. Guys, where are the PAs? Okay, go to the Gopher, the Google, the course page. If you scroll down, you should be able to find the golden link. Okay, among all these, among the many links. So click into golden. You will see the list of programming assignments. Okay, there will be a number of programming assignments, and the PA starts from teaching the basic unit commands, syntax of Go, and advanced to socket APIs and web API. Yeah, so this is something that I've already covered in one of the videos talking about grading, right? And so you know that there are 9 PAs. Hey guys, PA number 1, PA number 2, and down here, PA number 9. They are all released, in fact, okay? And so if you click into the link right after the assignment number, so for example, Unix command, you see the description of programming assignment number 1. So you read this through and you try to complete what's asked, okay? Downloading file, uploading file, logging out. Yeah, submitting PA1. Oh, there's no need to submit anything. You just need to log into the account we set up for you guys. That's a special server, Unix server set up for the class. You just log into your account and do all these things as described. And we'll check in your directory whether you have done your work, which is to exercise all these basic Unix commands. Okay. Now, if reading and following the PDF file is a little bit challenging, there are these videos. These are the walkthrough videos. You're seeing the video exactly Polly doing the Unix commands, okay? And that will make it very clear. So you should be able to follow just these videos and complete the assignments fine. And that is similar for each of the programming assignments below. Now for the first one, if you just watch the videos, it's straightforward. But for some of the assignments, the walkthrough videos only take you to some point, and you will need to finish the rest yourself. Okay. So the programming assignments are already provided. Okay. Now, what's not yet provided is the account. Okay, to access the course server. So that will be available when the team numbers are final, because each team is assigned an account. Okay, and you guys, according to the description, there's a certain directory, you name it a certain way, and that's where I'm gonna go there and check whether you have completed the assignment. And each member might want to do the assignment individually. Okay, what I would suggest you do is to create subdirectories within the account, and then work on the assignments within the subdirectories. Alternatively, you can try to work on the assignments on your own machine. So you could actually install Golang and then do the programming locally and do the testing by uploading it to the server. Okay, you should know better what I'm saying here. Okay, ways of working on the programming assignments as you try to do programming assignment number 2, 3, and 4. Okay, so essentially you 2 or 3 members of you will share one team account. Okay, and if you are a one-person team, of course, you have the freedom of doing anything within that account. And that account is based on your team number. So I will need to wait until Saturday, 6 p.m. to be sure. And if I am a little bit more sure before that, I would also post it, okay, here in the announcement, so you guys will know. And immediately following that, you can start working on PA1. Okay. Now, once you completed PA1, you know that you can already start working on PA2, 3, 4, 5. And I had a feeling that for some of you, the PAs might be straightforward. So feel free to work ahead of time and complete the PAs as you wish. What Polly would do is also maybe to check the different directories in your account and see how far you go. And as soon as I check and find that the assignment is already completed, I would assign grades also. Okay. All right. So there's a link in the programming assignment page called Port Assignment. Yeah. So this is something that you will need starting from PA4, because you'll be programming a server. When you are doing the testing, your server will need to run on the server. The reason that you need to upload the code you work on locally to the server to do testing is because we'll need to do the grading, confirming your code is working. And a more universal way of doing the grading is, or to establish a standard or baseline for grading, is that we test your code on the server, and so everyone will need to make sure that their code run on the server, the same environment. So that way we know that it's fair. Okay, so make sure that it works on the server, and we'll be testing your code on the server. And if it works, then you'll receive the full grade. Okay, so in a way, loading your code to the server is to ensure that you do not miss anything. You get the full grade for sure. Okay, and so starting from PA4, it needs to be a server. And so when you run the server on a machine, you need a port number. This is something that we'll talk about a little bit in chapter 2, but a lot more in chapter 3 and 4. Okay, but for a server running on a computer, it needs to be there needs to be a port number to set your server apart from other teams' server. Okay, because they are all on the same machine. That machine is assigned an IP address. Okay, so for a client to access the server, it tries to connect to that server's IP address. But if you guys' servers are all running on the same machine without different ports, there's no way for the client to differentiate or for the machine to differentiate which server exactly the client is looking for. So there's this port number to set the different servers apart. So each of you guys' server, although functioning the same, but there are still different servers, will be running on these special port numbers. So this is to avoid you guys' server colliding to each other. That would actually also generate error messages when you are trying to test your server. Okay, so this is the port assignment. And you see that the port number is corresponding to your team numbers. So essentially, for you to start working on the PAs, all you are waiting for is just the team number. Okay, and you know what? The server is not yet up running. Okay, so we'll see. We'll try to set it up and make sure that it runs as soon as possible. And once the team assignment is done by Saturday 6 p.m., you guys can start working on it. And for those who couldn't wait, how about setting up, installing Ubuntu, for example, on your laptop or home PC. Okay, start another partition, set up Ubuntu, and then you can start working on PA assignment 1 on your local machine. And so that it's easy and straightforward for you to complete assignment 1 when the server is up, when the account is assigned. Okay, good. So I hope it's clear. And you see that the course page is right here. Okay, if you just click into each link, you will see a lot more information that you might benefit from. So lectures take you to the YouTube channel where the stream is, where the live streams for the lectures are. Okay, so next week maybe we'll talk a little bit more about the individual links next. Okay, good. And you know what? It's already 12:17. Let's call it a day. And guys, go get lunch. So, bye. All right, bye, Hassan. Wonderful. Yeah, I know we are a little bit slow in terms of lecturing, but again, Polly would like things to be clear. Yeah, so good. Bye. See you next week.